0.002, and this one goes up. What's that?
7.46.
Don't go so fast, Jennifer.
I want to get through this.
All right, I'll give you that. I gotta sneeze. Sorry.
Why don't you sneeze?
I know.
Does it
Well,
tickle
I'll
you
sneeze when
with
it's
a fart or
time.
something?
Oh. So we're going to use the buffer equation again because we have an acid present and its conjugate base are present, both of them in healthy amounts, so we're going to use the buffer equation. It'll work great. 7.46, that's pKa plus log, base over acid. Now check this out. How many points do you think there are on the titration curve in which the acid and the base have the same amount? Only 1 point, and this is it. No. No, it's not that. It's got a name, in fact. But notice what happens. This is the same, so it's the log of 1. Those both cancel out. This is the log of 1. What's the log of 1? 0. 0. So pH equals 7.46. And I'm going to plot this point. At 20 ml, we're going up to 7.46, right about there. John, you tell me if I'm off. Oh, thanks.
Before we put it into the buffer equation, doesn't HOCl and OCl don't they have to reestablish equilibrium? Before we
Yes, they do, but remember, because that Ka value is so small, and because the shift to the right is so small, that goes down by some amount x and that goes up by some amount x, they really don't even change. We're neglecting the plus x and minus x, so just plug in those numbers. Okay, that's why we can do that. As I mentioned, there's only 1 point in which those two are equal to each other. Now, where are we in the titration? Are we at the equivalence point yet? What is the equivalence point when we look at these? The equivalence point is when that 0.004 moles all gets neutralized. Is it all neutralized? No. Where are we, though, in the process? We're halfway, aren't we? So chemists can be a pretty creative bunch. They call this point the halfway point.
Oh, meet me halfway, my Black Eyed Peas. You know that song? It's a good song.
I think I do.
It goes, meet me halfway. I forgot the lyrics, but it went something like that.
Yeah, yeah.
You were
It was
singing.
good. It was good. No, it was,
I'm pretty sure Elizabeth
Might go
wanted
viral.
to see that. Yeah, there you go. Your rapping thing.
so yeah, at the halfway point, that's where half of your original acid has been neutralized, and therefore you have half of the same amount of, I should say, the same amount of the acid as you have the base. At the halfway point, the pH and the pKa are equal to each other. This is the only point in the titration in which this happens because those terms cancel out. That whole term is 0, and therefore pH equals pKa. This is going to be really handy. You don't recognize why yet, but you get doing the problems and you're going to recognize, oh yeah, it's good to know what happens in the halfway point. Yes, sir?
They called it the quarter point.
I changed the name.
You didn't change it in the notepad.
That's what I just told John He. I know. I have since changed the name. Sorry about that. Yep, change quarter to half.
Quarter?
In the note packet, it says the quarter point. I don't like the name quarter point. I'm using halfway now.
It says halfway.
He doesn't like that.
I know, but on your paper it says quarter. Oh no, you got the new version of the note. Oh yeah.
What?
Yeah, it's.
Why is it
Judith asked me for a direct copy of this notebook file. That PDF was made a year ago. It's
You can have it.
No. Actually, it was March 28th.
I know what that sounded like. It was what year?
March 2011.
Oh, 11. Holy cow, I better update that.
God. It says 2015. So.
All right, Achoo. So we move on. We're going to take the next data point, which is 30 ml are added. How are we doing for time? Not well.
Can we just get through this?
You should have not asked so many questions and stalled us so much. So let's go ahead and get through it. 0.004 moles, still going back to the original amount. Now we've added 30 ml, which is 0.003 moles, and that's 0. Still limiting reagent is hydroxide, so that goes to 0. That goes down. We're getting closer, though. We've almost neutralized all the acid, down to 0.001 moles of it, and this is 0.003. Okay, this is going to be the last chance that we have to use the buffer equation.
No.
So let's use it. We got some acid, some base. pH equals 7.46 plus log.
0.94.
No, I mean, at least write this down, Jennifer.
No. We gotta get through this.
Okay, all right, 7.94. You have, fast forwarding through that math, we get pH 7.94. So we are well into the basic range here on our curve. 30 ml, 7.94, right about there. Tell me if I'm going too fast.
These hoes be
Okay.
basic.
Next point. 40 ml of the base are added. Now this is going to be a good one.
I said these acids are basic.
0.004 moles. That green is hard to read, isn't it? I'm not going to use it.
It's not a bad
The
one.
OH is 0.004
Is it?
moles.
It's okay.
This is the point at which all of the HOCl will have been neutralized on this very amount of base. So both of these run out to 0. Will you expect now, because I don't have any more acid and I don't have any excess hydroxide, is the pH going to go back to 7?
Oh, I think so. I think it should. It should.
What are you pointing at?
That OCL.
This thing right here. That's a base. And there is some of that still, isn't there? There's not any of this to make it acidic. There's not any of this, which would make it basic. But there is some of this, which makes it basic. This is 0.004. Yeah. Good find on that
Oh
one.
wait, Mr. Moore.
Yeah, that was nice. Yes.
OCl has to grab onto some hydrogen, but it can't grab it off of water because.
Yes, it can. This is exactly what a base does. And it's a weak base, so only a few of them grab them from water. This is the only thing now that's in the solution that can determine the pH. Because that's gone, but that is basic. That's going to make the solution basic. So once you hit the equivalence point, on the equivalence point, you need to recognize what is present and write the chemical equation for that stuff. If it's a base like this thing is, then you need to write it as a base in water. If this were an acid, then you'd write it as an acid dissociase, like NH4 plus yields NH3 plus H plus. Or with what? Yep, you could. We're done with the buffer equation because I don't have any of the acid left, so we can't. You'd have to have both to do the buffer equation. Yes? So that means this. We have to do the ice table. When we do ice tables, we have to use molarity. So that's number of moles of OCl. So that means the molarity is going to be 0.004 moles. Over the total volume, 40 and 40 is 0.08 liters. That divided by that is 0.05 molarity. How much HOCl is there to begin with? 0. It was all gone. But it is going to shift to the right sum. So it's going to go down by x and up by x for both of these. And I'm going to do it up here.
You want the answer?
Almost. KB. Now this is a base. We have to use the KB. Do not plug in that number for K. Jennifer, you didn't, did you?
Nope.
Good. KB is going to be KW over the KA, which equals x squared over 0.05. I'm going to put minus x, but then recognize, oh yeah?
Do you want the POH?
Okay. Yeah, you're going to get the POH when you do this thing, because this is a base. X is going to be the OH. pH is what?
4.7. No. I thought you wanted the POH. pH 9.23. 9.23.
I don't think it's 9. I think it's 10 point something. I think it's 10.08. Okay, well, let's see it.
Alright, 1 times 10 to the negative 14.
Jeez.
Hey!
Don't make the girls do it, Chucky.
Because divided by
Nothing wrong with girls, by the way.
3.5
I
to
don't know
negative
very
8.
good,
8 times 0.004. Right?
Well, no. Concentration, 0.05. That's what you
get
did.
10.07.
Ice table's got to have concentration, not moles. Because that K is the ratio of the concentrations, not the ratio of the moles. And they don't cancel out because you have two things in the numerator and only one thing in the denominator. So you got to say time out there. You do not use moles in the K's. You can for the bot equation, but not for the K.
10.07.
10.08.
Yep.
I don't know. I get 10.073. Honestly,
I
that's
don't
what my
know.
calculator
It's
says.
not
I don't know
that.
about you.
My calculator says that.
Whatever.
So at 40, we now have, oh my goodness, look at this jump. So look at our curve now. This doesn't look much like the curve that we had before. It's a very good curve.
So would the equivalence
I
point be
bet our lab's gonna do
considered
this.
as
And I could do
10.08?
this and figure this out.
Yes,
So much
that's the equivalence point pH.
So it's when all the acid or base has been titrated using the solution.
Right.
But the OCL could make it more basic.
It does make it more basic.
So the equivalent to the whole.
So there's no acid in there to kind of temper that base, so now the pH makes a big jump. So I would say write this down for yourself. The equivalence point of a weak acid, strong base
Is
titration.
that kind of given though?
Always
Because you're,
gonna be basic.
'cause you're given a strong base, so it's going to override the weak acid. Isn't that kind of given?
It is. It is. But really, at the equivalence point, all you have is the conjugate base. That is the true reason why it's going to be basic.
And then is it still gonna go?
It will continue up a little bit, but then level off.
Oh, again? That's cool.
So we are going to stop here. Now, we do have still a couple of data points left. We have to go past the equivalence point and see what's going on, but that'll be fine.
But was that one of the multiple choice questions that had multiple like?
That was for a diprotic acid where you had two humps there, two equivalence points for the two H's.
Are we going to do diprotic?
What do you think?
No, please no. Oh my god. Buffer than that. Boy, the second one won't. The